Day 228 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. You already know what it is, and today we have question number 101, symmetric tree. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. And today we're in the middle of doing the top 150 interview questions, so I hope y'all are excited about that. So let's get into the question. Question says, given the root of a binary tree, check whether it is a mirror of itself, i.e. symmetric around its center. So let's look at example 1 so we can see what they mean. In example 1, we have the input root equals a binary tree, 1, 2, 2, 3, 4, 4, 3. The output is true. As you can see in this picture above, you can see that they draw this line down the middle for us to see if it mirrors itself. So we can tell it mirrors itself because if we were to fold this down this, if we were to fold this binary tree down this line right here, then this 4 would line up with this 4, this 3 would line up with this 3, the 2 would line up with the 2, and the 1 would just be cut in half. It would line up with itself. So that's what we need to pay attention to. That's what we're looking for. And let's go through this just so we can see how it makes sense, right? So in the picture, right, we start with 1. That's where this 1 comes from right here. Boom. Then we go 2. Remember, we go left to right. So we go start with the 1, then we go to 2, then we go to 2, right? So it goes 1, 2, 2. Boom. Then we keep going, and remember, it goes left to right. So it goes 1, 2, 2. Then we come back to the left. It goes 3, 4, 4, 3. So then that's how this goes. 1, 2, 2, 3, 4, 4, 3. That's what it looks like in the input as compared, just in case you don't have a picture to go with, right? So it goes from left to right. Remember that, because that's going to be important when we're checking to see if it's a mirror, and I'll show you why in example 2. So let's look at example 2 where the output would be false, right? So in the input in example 2, we have the root. It's a binary tree of 1, 2, 2, null, 3, null, 3, and this time the output is false. So as you can see, it goes 1, 2, 2. Then we come here, since it goes left to right, it's a null, and since we have a value on the right side, we put null, then we put null 3, and then we do the same thing for the right subtree. It goes 1, 2. Right here, we check the left first, since it goes left to right, and there's nothing there, so we put a null. But since we have a value on the right side, that's why we put a null, and then it goes null 3 again. Now, as you can see, the difference between the first example and the second example, it goes 1, 2, 2, 3, 4, 4, 3. But in the second, well, yeah, that's the first example. In the second example, it goes 1, 2, 2, like it did at first, but then it goes null 3, null 3. Where up here it went 3, 4, 4, 3. Down here it goes null 3, null 3. So as you can see, the output is false, because this should be, if it was to be true, if it was symmetric, it'd be null 3, 3, null, right? Because if we drew that same imaginary line down this example, the 1 would be cut in half, the 2's would add up, but this 3 would line up with this null, and this null would line up with this 3, right? And that's not what we want, because that's not symmetrical, and that's why the output is false. So now that we understand the question, let's get into the fun part, the actual solution. I got 2 solutions for y'all today, so stick around for that. But before we get into the solutions, y'all, if you don't have any, or if you're looking for any new Apple AirPods, go ahead and check out that link in the description. Then after you do that, go ahead and like, comment, and subscribe, y'all. It's easy for y'all to like, comment, and subscribe. Just go hit that button for me, y'all. So now let's get into the solution. Now, the first solution, neither one are that difficult, but let's get into the first one. The first solution, what we are going to do is, first we're going to create a helper function. It's going to be a private helper function, and it's going to check to see if the 2 subtrees mirror each other. So this is the function we are going to use to see if the 2 subtrees mirror each other. We're going to say private func is mirror, is mirror, open up the parentheses, underscore left, colon, tree node. It's going to be a tree node. We're going to say question mark. Then we're going to say comma, underscore right, colon. That's going to be a tree node as well. Excuse me, y'all. Then that's going to return a boolean, just like so. Then first thing we're going to do is we need to create a base case to see if both nodes are nil, and if they are, then that means they're symmetric. So to do that, we're going to say if if left equal sign nil, comma, right equal sign nil, then we are going to return true. Then we're going to come over this now, and we are going to see if one of the nodes is nil or their values do not match, then the trees are not symmetrical, and we are going to check that by creating this guard statement. We're going to say guard left dot val equals right question mark dot val else. So it should be left question mark dot val equal right question mark dot val else. Open up the brackets, we are going to return false. So if the values do not match, we know it's not symmetrical. Now it's time to use a little bit of recursion, what we all know and love. First thing we're going to do is we're going to check if the left child of the left subtree matches the right child of the right subtree. So we're going to say return, is mirror, open up the parentheses, left question mark dot left, comma, right question mark dot right. Boom, just like that. Now we need to do the same thing. We need to check if the right child of the left subtree matches the left child of the right subtree. And in order to do that, we're going to say and, two and signs, and is mirror, is mirror, open up the parentheses, left question mark dot right, comma, right question mark dot left, just like so. So let's run it, see how it runs. Okay, we have an error. Let's see what the error says. Can I use optional changing? Let's see. So we have the guard left dot val equals right dot val. Hold on now. Let's see what we did wrong here. Guard left dot val equals right dot val else return false. I see. Let me see, y'all. Hold on. Oh, sorry, y'all. So up here, this should be an optional as well. Right now, we didn't have the tree node as an optional. So let's run it again. Oh, no, that's not going to work either, though, y'all, because we forgot to pass in the helper function. We need to come up here, and we need to say return is mirror, parentheses, root, comma, root, like that. My bad, y'all. Now let's run and see how it runs. Let's see, and there it is, y'all. It's accepted. So now that it's accepted, let's submit it. Make sure it stays accepted. Let's see. Get rid of this, and look at that, y'all. 0 milliseconds beats 100% of users with Swift. Not too bad at all. Those some good numbers right there. Now let's get into the second solution. Boom. Now, for the second solution, what we are going to do, this solution, we're going to use Equatable, which is a protocol that allows you to compare two instances of a type to determine whether they are equal or not. So in order to do that, we're going to come down here. We're going to say extension tree node, which comes from up here. The tree node is coming from this public class up here that LeetCode gives us. We're going to create an extension of that, and we're going to mark that as equatable. like that. Boom. Equatable. Make sure my spelling right. Now we're going to create a public static function, right? In order to do that, we're going to say public static func equal sign, open up the parentheses, LT, we're going to just say LT for left, colon, tree node, comma, then we're going to say RT, colon, that's going to be a tree node as well. This one doesn't need any question marks after the tree node, y'all, like last time. Then we're going to say that's going to be a Boolean as well. And we are going to say, now what we're going to do is, first thing we're going to do, we're going to check to see if the values are equal. In order to do that, we're going to say lt.val equal sign rt.val. Boom. Now after that, then we're going to say and, two and signs, and. Now we're going to check to see if the left child of the left node is equal to the right child of the right node, right? So in order to do that, we are going to say lt.left equals rt.right. Boom. But we're not done yet. Two more and signs, and now we're going to check to see if the right child of the left node is equal to the left child of the right node. So in order to do that, we're going to say lt.right, lt.right equal sign rt.left. Now we're going to come up here, and all we have to do is compare the left and right subtrees of the root using the equatable conformance. So this, we made sure the tree node conforms to equatable, and now we're just going to use that equatable conformance to check to see if the left and right subtrees, to compare the left and right subtrees. In order to do that, we are going to say root question mark dot left equal sign root question mark dot right. Now that should be all she wrote. Let's see, and that's accepted as well. So now let's submit it, see what that time looking like. Let's get rid of this and look at that, y'all. 0 milliseconds beats 100% of users with Swift. Again, that's what I'm talking about. That's what I like to see. So get one more look at the code, y'all. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.